Today we are going to talk about stoichiometry. First of all, what is it? Stoichiometry is about the ratio of different molecules in reactants and products of a chemical reaction. Stoichiometry calculation allows us to determine the amount of one chemical produced or required based on another given chemical. Stoichiometry is important for chemical labs, especially when using some substances with contamination. We must find the exact amount of chemicals to make sure a certain substance is thoroughly reacted. In everyday life, the idea of calculation with ratios is commonly utilized as well. For example, if you want to bake cookies twice as the amount of the one on the recipe, you will multiply the amounts of all the ingredients by a factor of 2. Now let's take this question as an example of stoichiometry calculation. Our purpose here is to determine how many moles of tetraiodide difluoride are produced by 5.4 moles of fluorine gas. Step 1, we will balance the equation. You can check my last video lesson to learn about it. Secondly, we determine the relationship of tetraiodide difluoride and fluorine gas. As we can see, 6 moles of fluorine gas produce 1 mole of tetraiodide difluoride. So the equation is set like this. Then the answer is calculated as 0.9 moles. Since we have solved the basic question, let's move on to another stage, calculations involving the moles bridge. In a chemical equation, the coefficients in front of the elements stand for the amount of molecules measured in moles in the simplest form. Because coefficients represent the ratio, the equation will be equivalent to this, and even this. In calculations, because moles are proportional, they are like a bridge to help us get other information like masses, volumes. Here is the example of the use of moles bridge. Step 1, unit conversion. We multiply 1.25 times 10 to the power 4 kilograms by 10 to the power 3 to convert the unit to gram. Step 2, we should calculate the amount of moles of hydrazine. As we can find on the periodic table, the molar mass of hydrazine is 32 grams per mole, which is composed of 14 times 2 plus 1 times 4. So we divide it by 32 grams per mole, which is to multiply the reciprocal of it. Step 3, the most important step. Based on the balanced equation, we know that the ratio between hydrazine and ammonia is 2 to 1. Therefore, 2 over 1 is multiplied after. Finally, as the question says, we convert moles to the volume at STP, which is 22.7 liters per mole. The answer calculated will be 1.77 times 10 to the power of 7. In conclusion, for this type of questions that are not asking for the number of moles directly as the first example, we will use the ratio of moles as a bridge to get the values we want.